Hi everyone, Assalamualaikum. In this video, we are going to continue application of first order ODE. Let me recall back what we have learned in the previous video, right? In the previous video, we have learned about population growth and bacterial colony and radioactive decay. So in this video, we are going to discuss Newton's law of cooling, right? Okay. We can use Newton's law of cooling in investigation, calculating the surface area of an object, in computer manufacturing, and solar heat water, right? Alright, under number 1, population growth and bacterial colony, and number 2, radioactive decay, we use formula dP over dt equals to Kp, and then we use parabol equation, then we can show that P equals to CEKT, okay, where P is an expression for population at any time t, right? So now we continue with Newton's law of cooling, okay, we start with dt over d time equals to K times T minus Tm. Then using parabol equation, we can show T minus Tm equals to Ce the power of Kt. Okay. And we can write T equals to Tm plus Ce the power of Kt. Okay. T here means an expression for temperature at any time T. Alright, because cooling here is based on the temperature. Alright, from this formula, okay, T equals to temperature, Tm equals to temperature of room or temperature of surrounding, T here means time, and K here less than 0, and it is constant cooling rate. Alright. Alright, now look at example 5 under Newton's law of cooling. A hot pizza is removed from an oven with a temperature of 95 degrees Celsius and placed in a room with a temperature 25 degrees Celsius. 5 minutes later, the pizza has cooled down to 60 degrees Celsius. Find the temperature of the pizza after 20 minutes. Alright? Alright, first, we extract the information from the question given. Okay, we extract time and temperature, and then temperature of room. Alright? Alright, we extract one by one from the given question. Alright, a hot pizza is removed from an oven with a temperature of 95 degrees Celsius. Alright, 95 degrees Celsius here means temperature. Okay, and from the word remove from an oven means just remove. Okay, so this is initial time. So we can write T equals to 0. Right? And then room with a temperature 25 degrees Celsius. So we can write Tm equals to 25 degrees Celsius. Right? Alright, so Tm here means temperature of room or temperature of surrounding. Okay. Alright, from the word 5 minutes later, so we can write time equals to 5 minutes. And then the pizza has cooled down to 60 degrees Celsius, so we can write temperature equals to 60 degrees Celsius. And then find the temperature means temperature equals to question mark, okay, after 20 minutes, okay, time equals to 20 minutes. Alright, from the information in the question given, we extract time, temperature, and temperature of room. Alright? Okay, after that, we can start from D temperature over D time equals to K temperature minus temperature of room. Okay? Then separating variables time and temperature. Okay? From D time here, we can move to right hand side and it become multiplication. And then from temperature minus temperature of room, we can move to left hand side. So we get this. 1 over temperature minus temperature of room, D temperature equals to K D time. Okay? And from here, okay, integrating both sides. Okay? We just put integration sign for both sides. Alright? Then we integrate left hand side and right hand side. Okay? When we integrate left hand side, okay, we can refer from, let's say we have integration of 1 over x plus 2 dx. It is equals to ln x plus c, ln x plus 2 plus c. Okay, we can use U substitution. Okay. Alright, now we have integration of 1 over temperature minus temperature of room. Temperature of room here means constant. Okay, from here. So the answer become ln temperature minus constant temperature of room. Alright, plus C, but we just put C on one side only. Alright, okay, and then integrate K dt, we can refer from, let's say we have integration of constant 2 dx. The answer is 2x plus C. So when we integrate constant with respect to time, so we will get constant times time, okay, plus C, okay, which is KT plus C. Alright, and then now we want to write temperature because we want to find the temperature, so we need to write temperature as a subject. So we have ln here, so we need to move to right hand side. Okay, so when we move ln to right hand side, it becomes E. Okay, so we have T temperature minus temperature of room equals to E to the power of KT plus C. Alright, and then from properties of indices, okay, we can separate E the power of KT plus C, okay, to E the power of KT times E the power of C from this formula, okay, under properties of indices. Okay, and after that, from E the power of C, okay, we can write constant C because E equals to an Euler's number 2.718 something, and constant, the power of constant will equals to constant. So we can write E the power of C equals to C. Okay, so now we have T minus Tm equals to CE KT. Alright, then we can write temperature, okay, equals to positive Tm plus CE the power of KT. Alright, so from D temperature over D time equals to K temperature minus temperature of room. Okay, this is ordinary differential equation, first order. Okay, we can use expression of variables, okay, to show temperature equals to Tm plus CE KT. Right? Alright, from the previous slide, we get T temperature equals to temperature of room plus CE KT. Okay, and after that, we can replace Tm equals to 25, okay, into this equation. So we get T equals to 25 plus CE KT. Then we can naming it as equation 1. Okay, and after that, the first row, t equals to 0, we can substitute into equation 1 to find c. And the second row, we can substitute to find the value of k. Alright? So now, to find c, we substitute t equals to 0, temperature equals to 95 degrees Celsius into equation 1. Okay? So from equation 1 here, okay, we substitute t equals to 0, okay, and temperature equals to 95 here, okay. Okay, and then we can simplify e to the power of 0 equals to 1, okay. Then we have c equals to 95 minus 25, which is equals to 70, right? So after we get c equals to 70, we substitute back into equation 1 here, okay? So we get t equals to 25 plus 70 e to the power of kt, okay? We substitute 70 into here, alright? Then we can naming it as equation 2. Okay, equation 1 and equation 2 are the same. But equation 1, we still don't know the value of c. And equation 2, after we substitute the value of c. Okay. Alright, and then to find k, okay, we use the second row. Okay, substitute t equals to 5 minutes and temperature equals to 60 degrees Celsius into the latest equation, equation 2. Right? So from equation 2 here, okay, we replace t equals to 5 and we replace temperature equals to 60. Right? Okay, then we can simplify. So we get e to the power of 5k equals to 60 minus 25 equals to 35. And then we move 70 to left hand side. So we get over 70. Okay, so we can write e to the power of 5k equals to 35 over 70. Alright? Or e to the power of k equals to 0.5. Okay, now we want to find k. So we need to move e to right hand side. Okay. So when we move e to right hand side, so we get 5k equals to ln. Okay. 0.5. So when we move e to right hand side, it becomes ln. Okay. Then using calculator, okay, we will get negative k equals to negative 0.13862. We divide ln 0.5 by 5. Okay. And after that, we substitute the value of k into equation 2 here. Okay. And k here is negative value because k is cooling rate. Okay. Constant cooling rate. That's why negative. Okay, because cooling means the temperature will drop. Okay. Alright, then we substitute k into equation 2. So we get t equals to 25 plus 70 e the power of, we replace k by negative 0.13862 and then t. Okay, here. Then we naming it as equation 3. Alright. Equation 1, we still don't know the value of c. Equation 2, after we substitute the value of c. And equation 3, after we substitute the value of c and k. Okay, we name as equation 3 to solve the other question. Okay. Alright, from the previous slide, we get T equals to 25 plus 70 e to the power of negative 0.13862 T, and we're naming it as equation 3. This is actually an expression for the temperature at any time T. Okay, so after that, we can substitute the last row into equation 3 here. Okay. We substitute T equals to 20 minutes, then we can find temperature T. Okay, we substitute into equation 3 here. Okay, so from equation 3 here, okay, we just replace T by 20 minutes. Okay, and then we can calculate using calculator. Okay, so we get temperature equals to 29.38 degrees Celsius. Okay, then we can write the temperature of the pizza after 20 minutes is 29.38 degrees Celsius. Okay, from this question, find the temperature of the pizza after 20 minutes. Okay, the temperature of the pizza after 20 minutes is 29.38 degrees Celsius. This is the final answer, right? Coming up next, Newton's law of cooling in investigation, which is application of separable differential equation. Thank you for watching. Stay tuned. Bye. Assalamualaikum.